Robinson annulation. Robinson annulation is a combination of three different reactions. The first reaction is a Michael addition reaction. The second reaction is the intramolecular aldol addition reaction. And the third reaction is the dehydration of the aldol addition product, which is also called as aldol condensation. Now all of these together at the end is going to give us a alpha beta unsaturated cyclic ketone. And in both of these reactions, Michael addition and as well as intramolecular aldol reaction, there is a formation of carbon-carbon single bonds. And why this is called as annulation? Because it results in the formation of a cyclic structure. Basically, ring formation reaction is an annulation reaction. Therefore, it has the name Robinson's annulation. Here is an example for Robinson's annulation. The first reaction right here is Michael addition reaction, where you can see that this is the 1,5-dicarbonyl compound that is formed in the Michael reaction. And the second reaction is an intramolecular aldol addition reaction, where you can see that the product is a beta hydroxy ketone here in this case. And the next reaction, the last reaction, is basically dehydration reaction, which leads to the formation of an alpha beta unsaturated ketone. In general, the product of the Robinson annulation reaction is going to be a fused 2-cyclohexanone ring structure. Let us now look into the mechanism for Robinson's annulation. Here we have an alpha beta unsaturated carbonyl compound, unsaturated ketone, and here we have a ketone. So in the presence of a base, the first thing that's going to happen here is the abstraction of the alpha hydrogen from the carbonyl compound. So here we do have two hydrogens. One of these hydrogens will be abstracted, and those electrons will be thrusted onto that carbon to form the enolate ion. So here is the enolate ion. Once this enolate ion is created, it's going to make a nucleophilic attack on this electrophilic carbon. Thrust these electrons to form the double bond between these two carbons, and the pi bond will break and it will shift its electrons towards oxygen. Here is the intermediate that is obtained, and here is the new carbon-carbon single bond that is formed between the enolate and the alpha beta unsaturated carbonyl compound. So this carbon right here is coming from beta carbon of the alpha beta unsaturated carbonyl compound. These electrons are going to be pushed in, whereby this double bond, which is now nucleophilic, will go and abstract an hydrogen from water molecule. This is the product for the Michael addition reaction. So this one is basically a 1,5-dicarbonyl compound, Michael addition product. Why this is an 1,5-dicarbonyl compound? You can see that when you consider this functional group, this is carbon 1, 2, 3, 4, 5. The second functional group is at the 5th carbon, right? So this is 1,5-dicarbonyl compound. Next, this is going to undergo an intramolecular aldol addition reaction because you do have two carbonyl groups, right? So this is a ketone and this is also a ketone. So this is going to undergo, this is a diketone, and therefore this can undergo intramolecular aldol addition reaction. So in the presence of a base, the alpha hydrogen will be abstracted. Let's find the alpha carbons. So here we do have an alpha carbon, and we do have an alpha carbon right there, and we do have another alpha carbon here. If you abstract these hydrogens right here, then it's going to result in a 4-membered ring structure, right? So that's not going to be feasible. However, if you're going to take this one, we cannot expect this enolate ion to go and attack this carbonyl carbon. That is also not going to be possible, right? Whereas if you're going to abstract these hydrogens, then it can create a carbanion, then it can create an enolate ion, which can actually go and attack this carbonyl carbon. We do have 3 hydrogens. And one of these hydrogens will be abstracted. It's going to form the enolate ion. So here is the structure of the enolate ion. And this enolate ion is going to make a nucleophilic attack on this electrophilic carbonyl carbon, thrust these electrons onto oxygen to form a tetrahedral intermediate. Let's see how many atoms are involved in the ring. 1, 2, 3, 4, 5, 6. So it's going to form a 6-membered ring structure. Therefore, it will be two fused 6-membered ring structures. If you want, you can also give the numbering on this, so it will be easier to put the substitution on it. So this carbon will be 1, 2, 3, 4, 5, 6. This numbering has got nothing to do with the nomenclature. So this is just, we are doing it for our own convenience so we don't miss out any substituents present on the ring. And we make the proper connections. This CH2 right here is trying to form a bond with this carbon, right? So let's write it down. So we should have two 6-membered ring structure which are fused together. If you assume this to be 1, this is 2, 3, 4, 5, 6. On carbon number 1, we do have a carbon-oxygen single bond which should have a negative charge on it. And on carbon 5, we do have the carbonyl group. So this is going to have the carbonyl group. And here is the new carbon-carbon single bond that is formed. Since we are talking about intramolecular aldol addition reaction, the product is going to be a beta hydroxy ketone. Here, there are no leaving groups, right? All of these are going to be strong bonds. Therefore, this O- will grab a proton from water and get it converted into a hydroxide group. So this will grab an hydrogen from here and it will get converted into the hydroxy group, thereby forming the beta hydroxy cyclic ketone. So since the two functional groups are in beta position with respect to each other, this is going to be beta hydroxy ketone, which is the product that is obtained in the aldol addition reaction. And in the next step, this is going to undergo dehydration to give us the alpha beta unsaturated ketone. So for which this has to be heated in the presence of hydroxide ion, and one of these alpha hydrogens right here will be abstracted. So the OH minus will go grab one of these alpha hydrogens. We'll abstract this, pushes those electrons onto carbon, and this will be resonance stabilized, where these electrons will go on to form a carbon-carbon double bond and thrust those electrons onto oxygen to give this intermediate. And in the next step, these electrons will be pushed back again to form the double bond. And this will go and try to form a double bond in the adjacent position. And this OH needs to leave, right? So this will take its lone pair of electrons and will try to grab the hydrogen from the water molecule. And finally, from here, you will be having your final product, which is going to be an alpha beta unsaturated carbonyl compound. So this is going to be the newly formed double bond. And there is already a carbonyl group that is existing in this molecule. This is our alpha position and this is the beta position, and you can see that there is unsaturation of the alpha and the beta position. Therefore, this is going to be an alpha beta unsaturated ketone, cyclic ketone. Robinson annulation on the whole is a combination of 3 different reactions. One is a Michael addition reaction. The first step is the Michael addition reaction. And the second one is the aldol addition reaction. And the third one is the dehydration reaction. So in this step, we are doing the dehydration. This would be the third reaction. Altogether, it gave us an alpha beta unsaturated ketone.